all, this is Mritala. Today I'm going to take you through one of the most talked about innovation of our generation, cryptocurrency. Cryptocurrency is not just about money on the internet, it's about how mathematics, cryptography, and network security have combined to create something that can challenge the way we think about banks, payments, and even trust. The title of my talk is Cryptocurrency and Cryptography Securing Digital Money. By the end of the presentation, you will see how cryptography ensures security, how network security ensures trust, why cryptography is considered both revolutionary and risky. So, what is cryptocurrency? Cryptocurrency is a digital currency, meaning it only exists electronically. But unlike normal digital money in your bank account, there is no bank, no middleman, no central authority controlling it. Instead, it runs on a decentralized peer to peer network. This means that thousands of computers around the world keep track of the system and no single entity can cheat. Here's an example. If I transfer 1 Bitcoin to you, that transaction is a broadcast across the network, verifying by many computers and then recorded forever in a public ledger. So, what makes cryptocurrency possible? There are two things: cryptography and network security. Cryptography is used to secure the transaction, and network security is to make sure that the system stays decentralized and resistant to attack. Popular examples you might hear of are Bitcoin, Litecoin, and so on. The evolution of digital money and relevance to cryptography. To understand why cryptocurrency exists, we need to look at the evolution of money. First, there were barter where people exchanged goods. Then came coins and paper money. Next, credit cards and debit cards made payment more convenient. Then came our online banking and digital wallets like Google Pay and PayPal. Now we have reached cryptocurrency, money that is 100% digital, borderless, and secured by cryptography. Why is it important for cryptography? Because cryptography is the science of securing information. It ensures privacy, authenticity, and trust, which are exactly the qualities we need in money. Without cryptography, cryptocurrency simply could not exist. Now, let's get into the heart of the system. You might wonder, how does cryptocurrency actually work? To answer that, we need to look into the three key components: blockchain, mining, and wallets. Firstly, blockchain. Blockchain is one of the backbone of the cryptocurrency. It's like a digital notebook or ledger that records every transaction ever made. Why do we need blockchain? Because if money is digital, we need a system that ensures no one cheats, no double spending, no fake money, and so on. Here's how it works. Transactions are grouped into blocks. Each block is linked to previous one using cryptographic hashes like a digital fingerprint. Once a block is added, it can't be changed. This makes it tamper proof. So, blockchain provides immutability, transparency, and trust without needing a bank. Next comes the mining. Now, who makes sure the blockchain is accurate? That's where mining comes in. Mining is a process of validating transactions and adding them to the blockchain. Miners solve very tough mathematical puzzles called proof of work. Why puzzles? Because these puzzles ensure that someone who puts in the computational effort can add a block. This makes the system fair and prevents cheating. When a miner solves the puzzle, they get rewarded with cryptocurrency like Bitcoin. This is how a new coin is created. So, mining is like the backbone of trust. It ensures that no one can easily cheat the system. Wallets. Now, if I own a cryptocurrency, where do I keep it? That's where wallet comes in. A cryptocurrency wallet is like a digital bank account, but instead of storing money, it stores keys. The public key is like your account number, you can share it with anyone. The private key is like your ATM pin, it must be kept secret because whoever has it can spend your money. This is why if someone hacks your wallets and cheats your private key, your funds are gone forever. There is no bank to call for recovery. So it summarizes: blockchain provides the record, mining secures it, and wallets lets us the access to uses. Together they make cryptocurrency possible. Since the topic is about cryptography, let's dive into the cryptographic concept that make cryptocurrency secure. The first one is the public key cryptography. Every user has a public key and a private key. The public key acts as the address, but only a private key can authorize your transaction. The second comes the digital signature. Using algorithms like ECDSA, transactions can be signed so that the network knows they are authentic. Hash functions are used in Bitcoins. A hash function converts data into a fixed length code, ensuring integrity. Even a tiny change in input completely changes the hash. Next comes the consensus algorithm. Proof of work and the proof of stake ensure all nodes in the network agree on validating transaction. This prevents fraud and double spending. What is a blockchain ledger? This is a cryptographic chain of blocks that ensure immutability. So, for each of these cryptography tools works together to make cryptocurrency secure and trustworthy. Cryptocurrency is a giant example in network security. First comes the peer to peer networking. Instead of central server, thousands of nodes around the world share the work. Each node has a copy of the blockchain. This makes the system decentralized and very hard to take down. Resistance to attacks. The network is designed to resist control common threats such as double spending, 51% attacks, cyber attacks, and so on. Double spending, where someone tries to spend the same coin twice. 51% attack is where a group controlling most of the network's power could manipulate transactions. And the cyber attack is where an attacker creates many fake identities to trick the system. Next comes the secure communication. All communication between nodes is encrypted. Every transaction is digitally signed. This ensures confidentiality, authenticity, and integrity. Consensus mechanism. Nodes must agree on the state of the blockchain. This agreement is what keeps the network synchronized and trusted. Cryptocurrencies are not just about payments anymore, they are expanded into many applications like digital payments, smart contracts, decentralized finance, cross border transactions. So, what are these? Digital payments are fast, borderless, and often cheaper than banks. Smart contracts are programmed to execute automatically when conditions are met. Imagine an insurance policy that pays instantly after an event without paperwork. Decentralized finance is like loans, saving, and investment done entirely without banks but on blockchain. What a cross border transaction! They are spending money to another country is instant to compare to traditional methods and services that take days and charges high fees. So, cryptocurrency is not more than money, it's a new financial ecosystem. But with great power comes greater risk. Cryptocurrency faces many challenges. Price volatility. Prices can jump or crash within hours. This makes it risky for investors and merchants. Risk of hacking and theft. If a private key is stolen, the money is gone forever. Energy consumption. Proof of working mining consumes huge amount of electricity. Regulatory issues are when some countries ban crypto, others embrace it, creating uncertainty. Fraud and scams, fake projects and scams trap many new users. These challenges make cryptocurrency both fascinating and controversial. To conclude, cryptocurrency is not just a buzzword, it's a living proof of how cryptography and network security come together to solve a real world problem. Cryptography provides the tools, privacy, integrity, and authentication, while network security ensures a global communication without a central authority. Together, they make digital money secure, trustworthy, and revolutionary. Of course, risks remain, but whenever you love it or fear it, cryptocurrency has already changed the way we think about money. Thank you.